Welcome to homework.
Okay, so we've got a bullet that's bouncing from a plate or sticking to a plate, and the question is which one exerts a greater impulse. So let's do it mathematically. So here's it going to be it bouncing, and here's going to be it sticking, right? So first, I'm just going to make up some numbers for a bullet, all right? Because this would work with whatever mass and speed. So let's say I have the bullet being shot has a mass of 0.01 kilograms, and that's supposed to be a bullet. Yeah, that looks even worse. And the velocity, let's say it's going 100 meters per second. All right, so the initial momentum of this bullet is the mass times velocity. So that's 0.01 times 100. So I made my life easy. It's just 1 kilogram meter per second. Okay, that's my initial. So let's look at what happens when it bounces and what happens when it sticks. Okay, so let's look at it bouncing first. So here's my bullet coming in, and then it's going to bounce off and come this way. All right, so change in impulse, I should say. Let's start with this. Impulse is change in momentum. I mean, impulse can also be the force times the time the force acts on, right? But the definition of impulse is change in momentum. So we're going to use that definition here. So in this case, my initial momentum is what I just calculated here, 1 kilogram meter per second. The final momentum, let's just assume this thing bounces off and comes back at the same speed, right? It doesn't matter. It doesn't have to come off at the same speed. I'm just going to use that. So our final momentum is going to be 1 kilogram meter per second, but it's going the opposite direction, right? Because remember, momentum is a vector. So I'm going to call the positive direction this way and the negative direction this way. So this is going to be negative 1 kilogram meters per second. Okay. So when you look at the bouncing one, change in momentum is impulse, and the change in the momentum is the final momentum minus the initial momentum. Well, when I do final minus initial here, my final is negative 1 minus my initial is 1. My change in momentum is negative 2 kilogram meters per second. Okay, let's compare that now to when it sticks. Right, so here, bullets coming in, right, and then it's just going to go and stick. So here, my initial momentum is again 1 kilogram meter per second, but my final momentum is 0 because it's going to squish against the wall and stop. So again, change momentum, final minus initial. Final is 0, initial is 1. 0 minus 1 is negative 1 kilogram meters per second. And so you can see when this sticks, you have less impulse than if it bounces. So let's pretend it didn't bounce at the same speed. Let's say it bounced off half as fast. This number would now be 0.5, right? And that means over here, this would be negative 1.5. See how it's still larger than 1? No matter what, if an object has the option of either sticking or bouncing, anytime you stick, you're going to have less change in momentum than if you bounce. You have more change in momentum, which is why a lot of times in car crashes and stuff, when you crash in a car, you don't want the car to bounce. You want the car to stick because there is less of a change in momentum if you stick than if you bounce.